Okay, so I'm going to walk through the analysis for the data for Lab 4. And here I've made up some numbers in this for a height difference of 5 centimeters. The height that you have in the lab will probably be something like 1.5 to 2 centimeters. All right, so I'm going to start with the third tab. So if you look at the bottom of Excel, you'll see I've got 3 tabs. I'm going to start with the angle and acceleration. And I'm going to, in the green area, I'm going to calculate the sine of theta and the uncertainty in sine theta. Then in this white area, I'm going to calculate the theoretical acceleration and the uncertainty in the theoretical acceleration. And I've got all the appropriate equations pasted in here. So for the sine of the angle is the height difference divided by the distance between the legs. So the height difference is here in B2. The length is in B4. So what I'm going to do is I'm going to go into this cell here for sine theta, and I'm going to type in an equation. So I'm going to do an equation. I'm going to say equals. That lets Excel know that I want to do a calculation. I want to do B1, which is, you can now see it's highlighted in blue here and blue there. B1, which is height, divided by this one here, which is B3, the length between the legs. And again, you can see it highlights it in a different color, so we can look at it, hit enter, and I get that my sine of my angle is 0.05. I never have to actually calculate what the angle is in this experiment. All right, the uncertainty in sine theta, look down here, uncertainty in sine theta, because it's a quotient, I'm going to use the multiplication division rule. So I have a square root sign. Underneath the square root, I put the two things that I'm calculating with, so height and the distance between the legs. So now I'm going to have a long equation. I'm going to type in all of this. So I'm going to type in equals sine theta. Now sine theta is up here in E1. So I'm going to say E1 times, and I'm going to have the square root. So in Excel you do SQRT, open bracket. And then I'm going to have this first term here, delta H, the uncertainty in delta H over delta H squared. So I'm going to do an open bracket. The uncertainty in DH is in B2 divided by DH, which is in B1, close bracket, and then square it. So now I've got this term. Next thing I'm going to do is I'm going to do plus, open bracket, the uncertainty in the length divided by the length. So it's going to be B4 slash B3, close bracket, squared. And then I'm at the end of my square root, so I'm going to close the bracket for the square root. And I don't know if you noticed, let me do it again. When I put in that bracket, you can see it. Excel flickers the bracket on the other side that corresponds with it, so you can look and see that you've got the right bracket. All right, hit enter, and it's done the calculation. So I've got my sine theta, my delta sine theta. Next thing is the theoretical acceleration. Theoretical acceleration is equal to g, which is 9.8 times sine theta, which we just calculated. So it's going to be equal to g, 9.8, times sine theta, which is E1. Okay, so my theoretical acceleration should be 0.49 meters per second squared. And the uncertainty in the acceleration, if I look at this long equation here, since I'm doing g times sine theta, I'm going to use the multiplication rule. And here, g doesn't have any uncertainty in it, so that term just vanishes. And so I can simplify it to it just becomes g times the uncertainty in sine theta. So I type in here equals 9.8 star. The uncertainty in sine theta is in E2, star E2. All right, so I've got my theoretical acceleration. Let me just write it down here. So I've got A theory is equal to 0.49 plus or minus, and I need to round that off, that 0.0098, I round that to 0.01. So that tells me that when I do my experiment, if I get values that go in the range between 0.48 to 0.50, if they overlap with 0.49, then I should be good. And then we put my units, meters per second squared. All right, so let's go and do the real work, which is going to be in the other tab. So let's go to the Part 1 tab. So Part 1 tab, I'm going to fill in all these columns in the spreadsheet using these equations, and then I got to do a couple of graphs. All right, so start off with the uncertainty and the displacement. So we had, if I draw a little picture at the side, we had 2 timers, and each timer we said we could tell within half a centimeter of where it was, so that's 0.005 meters. Okay, so each of these had an inaccuracy of half a centimeter. So together, if I take the difference between them, which is what delta S is, it's going to have an uncertainty that's going to be bigger than half a centimeter, because each of them could have been off by half a centimeter. So what we do then is, since the uncertainty is position 2 minus position 1, we have to add 2 of those uncertainties, square them, add them, and take the square root. That's called adding in quadrature. So I'm going to do, in this first cell in C, I'm going to say equals, now it's the square root, SQRT, open bracket, then I'm going to have delta S, which is 0.005 squared, plus, we're going to do that again, 0.005 squared, because the uncertainty in both the positions was the same. And I close brackets on my square root, hit enter. So I get 0.00707 is the uncertainty in displacement. And it's going to be the same for all of those. So I want to copy this down. So you notice I highlighted that cell. Then if I move my cursor around so I'm on the bottom corner, you'll see how that white plus sign cursor turns to a black plus sign. Now I can just click and drag that down the whole row, and it fills in the number. Okay, so I've got those numbers, uncertainty and time. Now, in the lab, we had all different uncertainties in time depending on the trial. So I'm just going to make up some numbers. Oops, that was way too big. That one's 0.02, 0.01. Okay, so I made up some uncertainties. You had some actual measured ones. All right, so now I got to calculate the last 2 columns. I got to do average V. So the average V is this equation, delta S over delta T. So delta S is displacement, so that's column B. Delta T is the time, that's column D. So I'm going to do equals B2 divided by D2. And hit enter, and it did the calculation for me. So I could have gone through with my calculator and done the calculations, but since Excel will do it for me, there's no reason not to do that. All right, so now I'm going to copy that equation down. So I could go down here and do equals B3 over D3, and this one equals B4 over D4, but since Excel will do that for me automatically, I'm just going to go over, grab that black plus sign, pull down, and it makes the equation for me. So if I click in this bottom one, you can see up here in the formula bar, it's got B11 over D11. All right, so there's my average V, and the uncertainty in the average V is this equation here. So again, because it's a quotient, we're going to use the multiplication division rule. So it's equal to average velocity, which is column F, so F2 star square root SQRT, open bracket. Then I'm going to make another set of brackets for this term here. So delta, the uncertainty in delta S, which is C2, divided by delta S, which is B2. And again, you can see it highlighted those, so I can make sure I'm doing the right columns. And then I'm going to do the uncertainty in time divided by the time squared, so it's going to be E2 over F2. All right, and if you're not sure, pause the video now. Sorry, not E2 over D2. If you're not sure, pause the video now. And you can see I caught that there because it highlighted it. I could see it was highlighting the wrong thing. All right. Pause the video, make sure I'm doing uncertainty in time over the time squared. All right, so I got everything there. Close the bracket on the square root, hit enter. All right, so there's my uncertainty in the velocity. And again, I don't want to retype that equation, so I'm just going to copy it down. Okay, so all my calculations are done. And I'm going to insert my graphs. So I'm going to have two graphs, one of average velocity on the y and time on x, one of displacement on y and time on x. So let me first start. I'm just going to make the graph. So let me see. I got, for the yellow graph, I've got time and average velocity. And I'm going to go insert at the top, insert chart. So I want to choose this scatter one without any lines. All right, so there's my graph. And I'm going to drag it over. That one goes there. And then I want one that's displacement and time. So let me click, I want displacement. And I want time. And then insert, chart, scatter. Okay. All right, so there's my graphs. All right, let me now check. So what you should always do is check your axes to make sure they're right. So I want displacement on the y-axis. So displacement goes from, if I look at my numbers here, from 0.2 to 1.1. And if I look, that's actually what's on the x-axis. And my time, which goes from 0.9 to 2, is on the y-axis. So that's the opposite way around. And Excel does that automatically. What it does is it chooses your leftmost column to be X and the rightmost column to be Y. So you can, what some people do is they just cheat and they just copy it over and make another set of data over here with them in the right order. Or you can go up to the top here and you can see under the Design tab there's Select Data. If I click on Select Data, I can hit Edit, and then you see it tells me for X it's doing B and for Y it's doing D. So I can select the correct things. So delete what it has in there. I'm going to say my X I want to be D. Click and drag. And my Y I want to be B. So I go and click and drag and B. All right, so now it looks like it's quadratic. And remember, that's what we're trying to get. We're trying to get a t-squared dependence. All right, so now my axis looks right for that. How about this one? This one I've got my x-axis going from about 1 to about 2, so that's the time. That's correct. And the y-axis goes from 0.2 to 0.6, and that's about right. Okay, so the axes look correct. All right, now I got to pretty these things up. So if I click on the graph, you'll notice I get plus sign, and I need a chart title. I need axis title, so I'm going to click there. I want error bars, so I'm going to click there. And I want a trend line. I'm going to come back and do that later, right? Because we're going to do special trend lines for them. And do the same thing over here. So I want axis titles, chart title, error bars. I don't want a legend, don't want any of those other things. All right. So now I got to put on my chart title. I'm not going to make it up for you. So you need to make something that describes what you're doing. So it never should be X versus Y, velocity versus time. So I'm just going to say make a title. All right, so you make up your own title for these guys. All right, and then let's do the axis labels. So they have to be correct labels and they have to have units. So I've got displacement. So displacement's in meters. And my select isn't working, so time is in seconds. And let's do this one while we're at it. I got the time in seconds. And displacement, no, what do I have here? Average velocity. And the units are meters per second. Okay, so I've got title, I've got axis labels. Now I need to pretty up my error bars. All right, so I'm going to go and edit my error bars. So for this one, the error bars, the horizontal ones, need to be my uncertainty in the time, which is column E. So I'm going to go click on those error bars. And what Excel does, when you tick to make error bars, it just makes them plus or minus 1 in each direction. All right, so if you just tick on error bars and I look at a graph and I see error bars that look like that, I know it's bogus. So I need to go over in this gray box over on the right hand side. I'm going to click custom, and specify values. So what I need to do is, for positive means the error bar length going to the right. Negative means the error bar going to the left. And you see it's put in 1 and 1. So I want those to be the uncertainty and the time. So I'm just going to click on that column E and put it in there. Same thing for negative. So I'm going to get rid of what it has in there and also put in the E. And now when I say OK, those error bars should get a lot smaller. So let me click out of there, and you can see they're there. They're just really small, so some of them are a bit even smaller than the data point. All right, let's do Y direction. So I'm going to click on the vertical ones, and you can see now in this gray box, it's come up with format error bars. I have to tick on this symbol at the top here with the 3 green lines to get back to where I can hit custom, specify value. And now you see there, these ones are all the same. So if I wanted to, I could just type in 0.00707. But let me just go ahead. It's probably just as fast for me just to grab it and do it. So for ones that are all the same, you can do it here. Or if you notice here in this gray box, there's also fixed value. So I could have clicked there and typed in 0.00707. All right, so now if I click out, see those error bars look smaller than the point. I can't see if there's any vertical error bars. All right, so my mean professor who's grading this is probably going to say you didn't put any vertical error bars. So I'm going to go into insert. I'm going to put in a text box. I'm just going to make a little note for the professor or for whoever's looking at the graph. I'm going to say vertical error bars are smaller than the points. All right, so then the person looking at it knows that, okay, they did do the error bars, they're just too small. So let me move that so it's not on my data. Okay, so let's go do the error bars on the other graph. So first let me click on the horizontal bars. And I'm going to go to the 3 lines there. Custom. Now let's see, I've got time is horizontal again, so it's going to be the same thing. Specify value. It's going to be my uncertainty and time, so column E. I'm going to get rid of what it has in there. Click and drag on E. Get rid of what it has in there. Click and drag on E. All right, so there's my horizontal. How about the vertical one? So now I'm going to go click on a vertical bar. Click on the 3 lines. Custom. Now vertically I've got average velocity. So I'm going to put the uncertainty in the velocity is my error bar. So that's going to be column G. So I'm going to click and drag. And click and drag. Okay, and let's see what we have there. Looks like, again, those vertical error bars are too small to see. So let's go to insert, put in a text box, and let's put it up here and say vertical error bars are smaller than points. Okay, so error bars are done. Let's see, whoops, I got a typo there. Correct it. All right, so error bars are done. I need to do trend line fit, and I need to get my uncertainties. One thing I'm going to do is looking at this graph, both of these graphs, you see I've got a lot of empty space in here. I don't really necessarily want that empty space in there, so unless it specifically tells you that you want to see the origin on there, I'm going to get rid of that empty space. I'm going to do it by clicking on the axis, and then again, if I go to the 3 lines, I go to axis options, I'm going to make my minimum value for the time. Oh, what's it look like? I think the minimum time was 0.9, so let me make it 0.8. And let's see, that should blow things up a bit. That looks a little bit better. And let me do the same thing for average velocity. Let me make it, so I'm going to click on that axis. And I'm going to make it 0.2, and then that should enlarge everything a little bit more. That'll help us see the error bars too. So now I need to move that a little bit. Let's go do the same thing with this one. All right, so let's go click on the bottom axis, 3 lines, axis. And what did we do? We did 0.8, I think, 0.8 for time. And displacement. And displacement looks pretty reasonable. Let's leave it like that. All right, so I've got everything now except for my line fit. So for the graph in the green area, that should fit the equation. Do I have the equation on here? Yes, I do. Go down a hair. So it should fit the equation here in the green box that it's going to be v0t plus 1/2 at squared. All right, so I want this to be a t squared, a second order polynomial fit. So I'm going to click on the graph. I'm going to hit plus and trend line. And depending on which version of Excel you have, you might not get a plus beside it. If you don't get a plus, go up into these chart tools, design, and you can do add a chart element up here in the top left. And you can access the trend line there as well. Okay, so I'm going to go to trend line, and it automatically puts in a linear one. I don't want it to be linear one. So I'm going to say more options. I'm going to get rid of, I'm going to have to delete my line. Let's see if I can do it. Click out, click on the line. Well, let me go. I'll just go over in the gray line. Let's see if I can do it. All right, so I want it to be a polynomial order 2. And darn it, it kept my straight line. All right, so I'm going to have to get rid of that, but I'll come back and do it. So polynomial order 2, and I always want to show the equation on the chart and the r squared. R squared is the goodness of fit, and r squared of 1 means it's a perfect fit. I'm going to pull that equation over so that it's not right under the data points. And I got to get rid of the straight line. Let's see if I can click on it. There we go. Got it. Click on it and delete it there. So I got rid of that straight line. All right, so that looks like a pretty good polynomial fit. I've got a 0.9985. And we'll come back and talk about that in a minute. For this graph over here, now I want to put a linear fit on it, because it should be fitting the equation v equals v0 plus a over 2 times t, which is a straight line. So, whoopsie, that was a bit far, wasn't it? I just want to be able to see the plus sign. Let's go a little bit. All right. Plus sign. I want to put on a trend line. I want to click here. Then I want to hit more options. All right. So I want trend line. Hit the 3 green lines again. Linear. I want the equation. And I want an r squared. And again, it put them in a bad spot. So let's grab them and drag them down where we can see it. All right. So I've got an equation on there that should match this equation over here. So the term that's in front of the slope term, 0.2438, that should be equal to my a over 2. The intercept term is my v0. So the way we did the experiment in class, we expect the v0 to be 0, and it's not quite 0, it's 0.0031. Okay, so I want to fit and get the uncertainty to see what I've got. So I'm going to use the linest fit. So I've made some areas here highlighted. So what I need to do is I need to select all 4 of these squares. Right? And now when you have all 4 of these squares selected, don't click anywhere else. Go straight up to the formula bar, which is right up at the top in here. Click in the formula bar and make sure that those 4 squares down here stayed highlighted. If it doesn't, you're going to have to go back and highlight it. Now in there I want to type in equals LINEST open bracket, and then it prompts me for what it wants. So it wants the known y value. So the y values for this fit is the average velocity. So that's this column here, column F. Select those values. Then I'm going to put a comma. Then it wants the known x values. The x is time, so that's column D. And then I put comma 1, comma 1, close bracket, and now here's the important part, Control Shift Enter. And in lab the other day, everyone was saying even on a Mac, it's Control Shift Enter, put it in, and then I get values here. So in this box, the first line is the slope, and you can see that that number is the same as what it said for the best fit there. Okay. And the second number here is the uncertainty in the slope. So slope and uncertainty in the slope. So if I compare it to that equation here, let me pull it back down again. All right, this slope is equal to a over 2. So a over 2 is equal to 0.244 plus or minus 0.007 if I look at my numbers. So to get a, I'm just going to multiply everything there by 2. So my a is 0.488 plus or minus 0.014. So that means that my experimental value for a is 0.488 plus or minus 0.0014. And that's good, right? Because if we go back to our tab that we had here for the theoretical value, our theoretical value was 0.49 plus or minus 0.01. So we got pretty darn good agreement there. All right, what's this other term? This other term is the intercept term. That's the initial velocity. So for me, my initial velocity was 0.003 plus or minus 0.01. So V0 is 0.003 plus or minus 0.01. And that 0.003 is less than 0.01. So if I put it on a number line, here's my value for V0, and my error bars go all the way like that. So it's definitely within error of 0. So again, the experiment worked out well. Okay, let's go over and do LinEst for our polynomial. So now we're going to have to do a slightly different LinEst. So I'm going to go in here. I've got to fit a t-squared term, a t term, and an intercept term. So I'm going to select all 6 of these cells. And again, don't click anywhere else. Go up into the formula bar, go equals LINEST open bracket. Now it wants the known y value. So y in this case is displacement. So that's b. Then I do comma. Known x is time again. So there's time. But now I have to tell it to do a polynomial fit to first order and second order. So I'm going to do a caret. So it's an uppercase on the 6. Then I'm going to do braces, open braces. So I want a curly bracket like that. And I'm going to say 1, 2, which tells it to fit a first order and a second order. Close the curly brackets. And then I'm going to do comma 1, comma 1 like we did before. Close the normal bracket and then Control Shift Enter. And when I scroll down, I've got all 6 of these filled in. So if I compare to the equation, the t-squared term is there, so that's going to be a over 2. The linear term, the t term, is v0, so that gives me my v0. And this term here gives me my initial position. Okay, so if I look at that, I can get my a over 2. And let me just erase here. I wrote a line over it. So a over 2 is going to be this first value, 0.22 plus or minus 0.03. And so then the acceleration then is going to be twice that. So it's going to be 0.44 plus or minus 0.06. So remember, our theoretical value was 0.49. Now our a measured is 0.44 plus or minus 0.06. So was this a good experiment? Well, it didn't turn out as well as my yellow graph did. But if I look at it, 0.44 plus or minus 0.06 means it could go, if I do plus 0.6, it could go up to 0.50, or it could go down, if I subtract 0.06, go down to 0.38, and my theoretical value is 0.49. So it's not as good, but it does overlap with the theoretical value. So I would say that this experiment worked out. Okay, so that's part 1. Let's go and do part 2. So part 2, I'm going to go to the last tab. All right, so last tab, again, I got to fill in my table first, and then I only have one graph here. All right, so uncertainty and displacement. Well, we only had one timer, and we said the uncertainty in the position of the timer was ½ a centimeter, 0.005 meters. So we're just going to copy that down. So that's easy. Uncertainty in the time. We had quite a small uncertainty in time for this part. I'm just going to copy what I have down here. We think in the lab we said it was 0.001 for all of them. All right, so there's my numbers. All right, V final. V final, if I look at my equation, is equal to the length of the sail divided by delta t. So the length of the sail is in this blue area here. So the length of the sail is 0.1. Then I'm going to divide by my t, which is in d. So I'm going to do equals 0.1 for the length of the sail divided by d2. And again, I'm going to copy that equation down. All right, so this one will be 0.1 divided by d3, 0.1 divided by d4, and Excel automatically changes the formula as it pastes it down. All right, uncertainty in V final is going to be from this equation here. Again, because it's a quotient, you should be seeing now all these equations are basically the same thing. It's going to be the V, which is this value here, so F2 star square root SQRT, open bracket. And then we're going to open bracket, we're going to do delta L over L squared. So length of the sail, we said, had an uncertainty of 0.5 millimeter, 0.005 over 0.1 squared plus the uncertainty in time over the time squared, so open bracket, E2 over D2. And since these uncertainties are constant, so I could just put 0.005 if I'd wanted to. And square that, and then close off the square root bracket, hit enter. And if you make any mistakes in the equation, it'll tell you. So it'll try and guess where your bracket should have been if you missed a bracket, for example, or it'll just tell you that there's an error. All right, so I copied that down. All right, next column is V final squared. Well, that's easy, right? So I'm just going to do F2 squared. F2 squared. And copy that down. And then the uncertainty in V final squared, here's the equation here. So V final squared is equal to V final times V final, right? So that's a product, so it would be V final squared times the square root of uncertainty in V final over V final squared plus the uncertainty in V final over V final squared. And since I got V finals inside and outside, it all simplifies down to this equation here. Okay, but if you wanted to, you could just use this equation, you'd get the same number. All right, so it's equal to root 2 SQRT of 2 times V final, which is F2, times the uncertainty in V final, which is G2. Enter. All right, copy that down. All right, so I got all my data. Now I'm going to make my graph in this pink region. And let's see, what do I want? I want VF squared on the y-axis. So it's column H, and displacement on the x-axis. So let me select displacement and VF squared. So when I select multiple columns, what I do is, let me tell you how to do that. I click and drag the first column. Then I let go of my clicking. I hold down the control button. Then I go over and click and drag in here. Okay, so I've got those selected. Then I'm going to do insert, scatter, put in my graph. I'm going to pull my graph down. And then let's see, I've got to have displacement on the x-axis should go from 0.2 to 2. That looks about right. VF should go from 0.2 to 2. That looks about right. So I can again check. So that goes to 1.73. That's about the right. All right, so I'm going to put in my labels. And it worked out right this time because displacement was to the left and VF was to the right. Put on, let's see, what do I want? I want axis titles. I want error bars. And we'll come back and do the trend line later. All right, so chart title. Again, I'm going to leave you to make up your own title. All right. Y-axis is V final squared. And I can just type in V final squared if I want, or I can do some formatting. I can do subscripts and superscripts. Let me just do it the lazy way now to move fast. I'm going to just say v final. Final squared. Why is it not typing in there? Okay. Oh, okay. So v final squared. And the units are meters squared per second squared. Okay, so that's that. And then this one is displacement in meters. Okay, you're going to make up your own title. I'm going to do the error bars. So I'm going to click on the horizontal error bars. Horizontal error bars, they all have the same value. So again, go over here, click on the 3 green lines. And they're all the same, so I'm going to be lazy. I'm going to say fixed value 0.005. And to put them on, you see they all shrank to really small. I can't even see them. Vertical error bars, custom. Now I'm going to specify value, and vertical is VF squared. So we're going to use uncertainty in VF squared. So it's going to be column I. So click and drag. Click and drag. And say OK. All right, so I can see my vertical error bars. You can see they're different size for each one, which is in agreement with what we have. But I can't see the horizontal one, so let me put in a little text box just to let everybody know that the horizontal error bars this time are smaller than the points. All right, last thing is put on the line and get the slope and the uncertainty in the slope. So I'm going to insert, click on here, and I want to add a trend line. And why is my plus sign not coming up? All right, so my plus sign for adding the trend line didn't come up this time. So I'm going to do it. I'm going to go to chart design, add chart element, trend line, more options. All right, so I want linear, display the equation, display the r squared. So there they go. I'm going to drag them down there. So what I'm fitting this time is that v squared is equal to v0 squared. So this now is my intercept. v0 squared is my intercept. And the slope is 2a. So the slope 0.9874, that's twice the acceleration, and this 0.0113, that's the initial velocity squared. All right, so I want to get the uncertainty in those values, so I need to do line est. I'm going to go up here into my pink area. You can do it anywhere you want. I just was trying to make it easier to point out what's where. So again, select those 4, go up in the formula bar, equals LINEST, open bracket, known y value. So y is v final squared, so there, comma, known x value is displacement, that's b, and then it's a linear fit, so I just do comma, 1, comma, 1, close bracket, control, shift, enter, and there's my value. So my slope is 2a is 0.987 plus or minus 0.014. So to get a, I'm going to divide that by 2. So I get 0.494 plus or minus 0.007 is my measured value. And remember, my a theory was 0.49 plus or minus 0.01. So again, I've got good agreement with the experimental values because it overlaps with the theoretical values. Okay, so that's all there is to it. So when you're done, grab a screen capture of your graph. So usually on a PC, I use the snip tool. So you can search for the snip tool, which will come up looking like this. I can say new snip, and then I can just select and grab. All right, it copies it. And then at this stage, I can save it. And then I can import my saved picture into my worksheet document. Okay, so for now I won't save it. All right, that's all there is to it. Good luck.